Okay, let's do the math now. This is where it gets a little trickier for some of you. So you drive west. This is you. West is in this direction at 20 miles per hour. And your friend drives east at 30 miles per hour. So if you guys are traveling in opposite directions and you are moving in this car, to you, it will look like these two speeds are going to add together. And you get 50. Now, the only tricky thing is understanding which direction they're traveling in. Since you are traveling west and they are traveling east, if you're going west, it'll look like they're still traveling east, but just at a greater speed than they actually are. Okay? So it will look like they are traveling 50 miles per hour east to you. So let's go to the next problem. You're watching a train that is traveling to your right at 22 meters per second. So this is one of those scenarios where you are sitting off to the side. You're just watching a train go by for whatever reason. Choo-choo, right? So perfect train. Chugga, 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 chugga. All right. It is traveling to the right at 22 meters per second. For whatever reason, your friends, being the daredevils they are standing on top of the train, and they're traveling this way at 7 meters per second. You know this because it says your friends are running in the opposite direction of the train's motion, which is to the left at 7 meters per second, and your friends are on top of the train. So we know based on the chart they're subtracting. So 22 minus 7 gives us an answer of 15. And remember, all we got to do is look at the bigger number. So the bigger number is to the right. So your friends will still look like they're moving to the right, just a little bit slower than the train itself is traveling, or people in the windows. You're looking to a person in the window, it would look like they are definitely moving at a faster speed than your friends are on top of the train. All right. Next example. So you're traveling in a car when you get stuck behind a driver's ed student. Typical. Plenty of you have probably suffered that fate or been the driver's ed student and seen other people driving by you and you're like, look at these dang kids going so fast these days. I can't. They're going to get in a wreck. And then you eventually become the person you hate. Very classic story. Tale as old as time, honestly. Anywho, you're running late and you need to pass them. So we have this person, driver's ed, going 65. You got to pass them. Speed racer over here, speed demon, going, a risky 80, right? So you're both traveling in the same direction. They're just going slower. So to you, it will look like they are going this way, but at a slower speed, because when you look at your chart, it'll look like they're going backwards 15 miles per hour. Does that make sense? You can say it backwards since I didn't specify directions. Or back, whatever. Okay. I have one last example. And hopefully you'll be able to do the rest of the stuff on your own. So Mario is traveling 17 meters per second east and throws a banana behind him at 12 meters per second west. What is the speed and direction of the banana relative to Mario? Okay, so we got Mario traveling. Watch this beautiful. I practiced it a couple times because I kept messing up the recording. See, is it better? Okay, not too shabby. You can kind of see what it is. All right, Mario, he's got a little bit of a belly because he is a plumber. And if you've ever played a game, you'll know he isn't in the greatest shape. in the world. All right. Look at this mustache that he's going to have. His big old Mario nose. And then he's got his cap. The famous Mario cap. Look at this. What a masterpiece. Look at beautiful. All right. He's traveling 17 meters per second east. 17 meters per second. He throws a banana. The banana is a little going this way at 12 meters per second east. So this scenario can be looked at one of two ways. So it will be the number right here where it is 17 minus 12, and we get 5 meters per second. From Mario's point of view, it will look like it is traveling 5 meters per second backwards. But if we took it from an observer's standpoint, it will look like the banana will still be traveling in overall direction of 5 meters per second to the east. Because it's a lower value than Mario's overall speed, it will still look like it's traveling in this direction, just at a lower value, in this case, 5 meters per second. Once it hits the ground, it'll slow and stop, but that's because of other things like friction. If it landed and it didn't lose any energy somehow, there was no friction, it would just continue traveling at 5 meters per second east forever. Okay? Here's a quick little video I made just to kind of show you this concept. So, I'm going to demonstrate what I was talking about just now, where I'm going to throw a ball behind me, yet it's still going to roll towards me in that direction. So, hopefully you don't see my nasty feet, but if you do, sorry. Alright, so if I start walking in this direction, right, at about that speed, you can kind of get a general gist of how fast I'm going. And now if I throw the ball ever so slightly behind me, you'll see the tennis ball will continue in that direction. Okay? Just like that.